x. Let's go ahead and get started with today's problems. First of all, numbers 1 through 7, the directions say to add, subtract, multiply, divide the functions, and then tell the domain of the division problems. Okay, so with that in mind, let's go ahead and get started with the first problem here. Okay, we're going to add these two together. So x plus 2. I'm going to go pretty fast through these, okay? Plus x minus 2. There's a positive sign here, so nothing changes. There's a positive sign here, so nothing changes. So x plus x is 2x, and 2 minus 2 is 0. So the answer is x plus, hold on 1 second if I mess up here, let's see, 2x. Yes, the answer is 2x, okay? Now let's go ahead and subtract these two functions. So we have x plus 2 minus x minus 2. This minus sign right here is going to make everything in your second parentheses change their signs. So the positive x becomes negative, the negative 2 becomes positive. There's a positive sign right here, so nothing changes here. Now combine your like terms. Your x's cancel, positive x and negative x. 2 plus 2 is 4, so the answer would be 4. Next we're going to multiply these two functions. So let's go ahead and get ready to do that. Okay, we're going to take this x right here and multiply it through, and then take this 2 and multiply it through. X times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. 2 times negative 2 is negative 4. Your middle terms here cancel out. Positive 2, negative 2, and you're left over with x squared minus 4. Okay, now let's go ahead and divide these two functions. So we have x plus 2 divided by x minus 2. Now students, I'll be honest with you, there's really nothing you can do, okay, to simplify this. Do not cross off your x's. You cannot do that. The only way you could do that is if there was an x with every term like this, okay, which there's not. Don't cross off your 2's. The only way you could cross off your 2's is if there was like a 2 here and an 8 here, so you could, 2 goes into all of these, okay, and that's not the case, so you really can't do anything with this. This is your answer right here, okay? Now having said that, they want us to find the domain. Well, the numerator really has nothing special about it. Any number can go in the numerator. In the denominator, you cannot use a negative 2. Any other number works. So the domain for this function is all real numbers, so that x does not equal 2. So actually it'd be a positive 2. Sorry about that. There we go. So x is all real numbers. All real numbers such that x does not equal 2. Alright, moving on to number 3. Okay, we have x squared. Then we have 2 minus x, okay? So the first thing we're going to do is we're going to subtract. We're going to add these two functions, okay? So, we'll bring down our x squared. Here we got x squared plus 2 minus x. Nothing outside the parentheses, so it stays the same. A positive here, so it stays the same. And there's your answer. Now if you want to write it in standard form, x squared comes first, then your x, then your positive 2. Either way, there's your final answer when you add the two functions together. Alright, now let's subtract these two functions. So here we go. Positive sign out here, so the x squared stays the same. Multiply your negative sign through. 2 becomes negative, x becomes positive. Once again, this is an acceptable answer, but if you want to write it in standard form, your x squared comes first, then your positive x, then your negative 2. I will accept either one of those two answers. Okay, moving on to multiplication, okay? Now we're going to multiply these two functions. So we have x squared times 2 minus x. So simply take your x squared and multiply it through. X squared times 2 would be 2x squared. X squared times negative x is negative x cubed, okay? Now that's totally sufficient. If you want to write it in standard form, your highest exponent comes first, and then your next exponent would come next, okay? That is the correct answer. Either one of those two are sufficient. goes in the bottom. Alright? Now students, there's nothing you can do. You cannot simplify. You cannot reduce that. You cannot cross off the x's. This is your answer. What would the domain be? Well, anything works in the numerator, that's fine. In the denominator, x cannot be 2 because 2 minus 2 is 0. So the domain is just like the last problem. All real numbers such that x does not equal 2. Okay? Alright, moving on to number 5. Our f function is x squared plus 6. And our g function is the square root of 1 minus x. Alright, now we're going to add those. So x squared plus 6 plus the square root right here. 1 minus x. Alright? Nothing out here, so we bring down our x squared plus 6. Positive sign here, so we bring down our square root. And there's nothing else you can do, students. There's nothing you can do with that, okay? That is your answer. Alright? So, there we go. Moving on now to subtraction. Let's subtract these two functions. Now, there's a positive sign here, so none of these change. X squared plus 6. There's a negative sign here, but remember, the negative sign does not go to the terms inside the radical. It goes to the outside. There's a positive sign here. So this negative times a positive gives you a negative square root of 1 minus x. You do not change the numbers on the inside. Okay? Now, having said that, that is your final answer. There's nothing else you can do. Nothing. Okay? Now let's multiply these together. Okay? Let's multiply these. So here we go. Now, students, please listen to me carefully. This is one big term. This radical is pulling all these together. So you have to make it one term. So you take x squared times the radical. That would give you x squared square root 1 minus x. Okay? Then you take 6 times the radical. That would be a positive 6 square root of 1 minus x. Now this is a totally sufficient answer right here. Okay? No problem with this at all. However, probably a lot of books would want you to factor out what's common, and both of these terms have a square root of 1 minus x. So if you pull that out, you're left over with x squared plus 6, which is really what you started with up here. But I'll be honest with you, I would accept either one of these two answers. Okay, I'm fine with either one of those. Okay, and so lastly now, we're going to go ahead and divide these two. So our f function goes up top, and our g function goes in the bottom. Alright, now students, there really is not anything you can do here, except they might want you to rationalize, like multiply the top and the bottom by the square root of 1 minus x, but on a test or a quiz I would tell you not to do that, okay? So there's really nothing you can do. The only thing left to do is to find the domain, like they asked us to do, okay? So, the numerator, there's really nothing special about the numerator. There's no fractions in the numerator. There's no square roots or anything like that. So to be honest with you, the only thing we have to worry about for the domain is my denominator. Now first of all, in a square root, your 1 minus x must be greater than or equal to 0. You can never take the square root of a negative number, so bring the 1 over and make it a negative number. Then hopefully you remember from Algebra 2, whenever you divide an inequality by a negative number, you turn the arrow. So divide both sides by a negative 1. This becomes positive. Your arrow turns, and this becomes positive. So there's your domain. Listen to me. Almost. Almost that's your domain, because look, you're saying right now x has to be less than or equal to 1. So you're allowed to put 1 in, which is fine. So if you put a 1 there, the square 1 minus 1 is 0, and you can definitely take the square root of 0. So normally that's okay. But if you put a 1 in and you get the square root of 0, the square root of 0 is 0, and you can never have a 0 in the denominator. So in this case here, x has to be less than 1. It cannot be equal to 1, okay? Because if you put 1 in, you get the square root of 0, and the square root of 0 is 0, and you can never have 0 in the denominator, so this would be your domain right here, okay? Moving on to number 7. Alright, first of all, we're going to add these. So we have 1 over x plus 1 over x squared, okay? Now, obviously, if we're going to add two fractions, we have to get a common denominator, okay? There's 1x here, 2x's here, so I'm going to use x squared for my common denominator, okay? Now, if I were to divide x into x squared, I would get x. Think about it, guys. If I took, let's look at it like this. How many extra x's do I have here compared to this? 1. I have 1 extra x. Then multiply it times your top. 1 times x is x. How many extra x's do I have here compared to this? None. So just bring your 1 down. There you go. And now you have x plus 1 over x squared. Okay? That's what you would get when you add the two functions together. Now moving on to subtraction. The common denominator is going to stay the same, x squared and x squared. Now, how many more x's do I have here compared to this? 1, and 1 times x is x. How many extra x's do I have here compared to this? None. Bring your 1 down. So now you subtract your two fractions, x minus 1 over x squared. Okay, so that's what you get when you subtract the two functions. Now let's take a look at multiplication, okay? We're going to multiply these two functions together. And so here we go. 1 times 1 is 1. X times x squared is x cubed. So 1 over x cubed. Now we're going to divide these functions, alright? And so here we go. We have 1 over x divided by 1 over x squared. Okay? Now here's how you simplify this. You really have 1 over x, this fraction here, divided by, that's what this big line means here, divided by this fraction here, 1 minus x squared. Now, we multiply the two fractions, and we flip the second fraction. Alright, now we can do some cross canceling. We have 1x here and 2x's here. Take 1x away from this, we're left with 1. Take 1x away from here, we're left with x. So 1 times x is x. 1 times 1 is 1. So you will end up with x for the division, okay? So the domain for that should be all real numbers, okay? The domain for that would be all real numbers. Now, I will say this, before you reduced it, you had x squared over x. So some would say x is all real numbers, so that x does not equal 0, because there was an x in the denominator before you reduced it. I don't get that picky. The main thing to know is what the domain of your final function is, and that would be all real numbers. Alright, moving on. Let me get a drink here, and we're going to continue on. Okay, we're looking at numbers 9 through 17. The directions say to evaluate the function for, okay, I didn't write the directions down. Okay, you're using these two functions here. Let me write these down for you, and then we'll copy these over and over for every problem. So in your directions, you will see this function here. And in your directions, you will see this function here. So these are the two functions we're going to use. Alright, let me copy this real quick. And here we go. Alright, f plus g of 2. So we're going to add these two functions together. Positive sign here, so it stays x squared plus 1. Positive sign here, so it stays positive x minus 4. Combine all your like terms, and you're left with x squared plus x minus 3. Now, students, if they had asked us to just add the two functions, we'd be done, okay? But notice it says f plus g of 2. So everywhere there's an x, we're going to put a 2. And if you combine combine these. 4 plus 2 minus 3 is 3. Okay, now students, I'll be honest with you, there's a faster way to do this, and I'm probably going to start doing these the faster way. You can also put 2 in first for your x, and then add the 2 together. For example, put a 2 in here. 2 times 2 is 4 plus 1 is 5. Put a 2 in here. 2 minus 4 is negative 2. Add those two numbers together, and you get 3. That's a lot faster. In other words, you can put the 2 in first and then add the two numbers. The reason that's faster is it's always easier to add two numbers than it is to add all of these algebra terms, okay? So, anyways, I'm probably going to do mine like that from now on to save time. For example, we're going to subtract these two functions. And so, for now here, to be honest with you, since we're not putting a number in, but we're putting 3t in, I'm going to go ahead and subtract the two functions first. I think that'd be better. Okay, x squared plus 1 minus x minus 4. Okay, there's a positive sign in front of this parentheses, so everything stays the same in front of that parentheses. Here there's a negative. Multiply the negative through, you'll get a negative x and a positive 4. Now if you combine like terms, you have x squared minus x plus 5. Okay, now we go ahead and we put 3t in for x. So we have 3t quantity squared minus 3t plus 5. If you square 3t, 3 times 3 is 9. T times t is t squared. Minus 3t would be negative 3t. And then plus 5. There's no like terms to combine. That's definitely as far as you can go. Alright, moving on to number 13. Now here we're putting 6 in, okay? So, first, we're supposed to multiply the two functions together and then put 6 in. But for me, I'm going to put 6 in first and then multiply. So I have 6 squared plus 1. Over here I have 6 minus 4. 36 plus 1 is 37. 6 minus 4 is 2. Multiply those two together and you will get 74. Remember, we're multiplying, so the number you get out here when you put 6 in for x, and the number you get out here when you put 6 in for x, you multiply those two together. Since we're multiplying, 37 times 2 is 74. Alright, number 15, I'm going to put a 5 in first, okay? So, for my x right here, I'm going to put a 5. And for x over here, I'm going to put a 5. Now, 5 squared is 25 plus 1 is 26. 5 minus 4 is 1. So we take 26 and we divide it by 1. And if you do that correctly, you will get 26. Okay, 26. Moving on to number 17. They want us to find f divided by g of negative 1 minus 2 times g of 3. So let's really just take our time on this and not panic, okay? It looks really complicated, but it's not too bad, okay? Now, first of all, I have f divided by g of negative 1. So I'm going to put a negative 1 in for x real quick here. And a negative 1 in for x. Now watch. Square the 1. That's 1 plus 1 is 2. Negative 1 minus 4 is negative 5. So there's my two numbers. Now I put negative 1 in for f, and for x, I put negative 1 in for x. I got these two numbers. Remember, they're dividing, okay? So this whole expression right here ends up equaling what? 2 divided by negative 5. And of course, 2 divided by negative 5 is just really a negative 2/5. Alright? Now, let's move on to the next part of the problem. Now, we are told to take minus, see this negative sign, so I'm going to put a negative sign here, 2 times g of 3. So we're going to take 2 times g of 3. Now what is g of 3? That means in the g function, everywhere there's an x, we're going to put a 3. So 2 times g of 3, well, that would be 2 times negative 1. 3 minus 4 is negative 1. 2 times negative 1 is negative 2. So we have minus a negative 2. So we end up with negative 2/5 plus 2, which should give us 1 and 3/5, okay? Negative 2/5 plus 2 is 1 and 3/5. And the answer in the back of the book says 8/5, which is the same thing as 1 3/5. Okay? Look that over again if you need to, alright? Moving on to number 19. Now the directions for 19 through 21 say graph the functions f, g, and f plus g on the same set of coordinate axes. Okay, so this one we only have two of these, so it shouldn't be too bad. Okay, I'm gonna graph this one here in black. I'll circle it in black. I'm gonna graph this one here in red. Okay, and then I'm going to graph f plus g in green. Alright, so here we go. Here's my coordinate plane. Alright, let's start with the black here first. And here we go. Y equals 1/2 x. Now that's a linear equation. So just put a 0 in for x real quick. And you get out a 0. And then put in a 2 for x. And you get out a 1. That's pretty simple. So 0, 0, and 2, 1. So the line will look something like this, okay? Okay, now we're going to move on to red, okay? This is a linear equation. Y equals x minus 1. Okay, so let's just get 2 quick points. Put a 0 in for x, and you get out negative 1. Put a 2 in for x, and you get out 1, okay? So 0, negative 1, and 2, 1. So here we go. Okay, let's graph this f plus g function in green. If you add these two together, you get 1/2 x plus x minus 1. So you get 1 and 1/2 x. Okay, students, here we go. Now, we have 1/2 x plus 1x. That would be 1 and 1/2 x minus 1. So I'm going to put 3/2 of x, because 1 and 1/2 is 3/2 minus 1, okay? So here we go. Let's see, it's a linear function, so real quick, put a 0 and you get out negative 1. Put a 2 in, and you would get out 2. 3/2 times 2 is 3, and 3 minus 1 is 2. So I have 0, negative 1 right here, and then 2, 2 right here. So there we go. So there's the black line and the red line being added together, and you get the green line, okay? Pretty cool to get a picture of it, alright? Okay, let's go on to the last one in this section, number 21. Now, again, we'll use the same color code. I'll graph this one in black, I will graph this one in red, and I will graph f plus g in green. I'm going to very quickly find what f plus g is, okay? F plus g would be x squared plus negative 2x, which of course would be x squared minus 2x, okay? So there we go. I'm going to quickly erase this and just pull this up here and say to you, there's your f plus g right there. Alright, so let's start with this function over here. Notice, students, this is a quadratic, okay? So we are going to get a parabola. And so, to be honest with you, we know this graph. We know the model graph. We learned this recently. The model graph of this would be 0, 0, 1, 1, negative 1, 1. I'll show you right here. Okay, guys, here we go. We're going to start off with 0, 0, 1, 1, negative 1, 1, 2, 2, negative 2, 2, and hopefully you get the idea. It's a parabola, and it will look something like this. Guys, you really should start learning to recognize these functions, okay? You should know that a quadratic is going to give you a parabola, okay? Now let's talk about the g of x function. Y equals negative 2x. Now that's going to be linear, okay? That's a linear function. So put a 0 in, get out a 0. Put in a 2, and you get out negative 4, okay? So put in a 0, 0. You get this, and then 2, negative 4, right here. So there's your line right here. Alright, there we go. Now, the last function, students, where you added the two together. And I'm not sure why I didn't do that in green, but when you add those two together, you're going to get this right here. Okay? So here's our equation. It's y equals, I'm going to do it down here, y equals x squared minus 2x. Okay? Now, that is a quadratic, okay? So students, please listen to me. You can use your grapher if you want to, and type it into your grapher and get a picture of it. Instead, I'm going to very quickly just find the vertex on my own. Remember, to find the vertex is negative b over 2a. So b is negative 2, so negative 2 over 2 times a. A is 1 right here, if you remember all that from algebra. It's 2. So a positive 2 over a 2 is 1. So I know my vertex is going to be at 1. So put in a 1, and you get out negative 1. And then from there, just think about some other points. Put in a 0, put in a 2, and put in a 0, you get out 0. Put in a 2, no, put in 2, and you get 4 minus 4, you get a 0. And I'll try a couple more. Put in a negative 1, and put in a 3. Put in a negative 1, you get a negative 1 out, I believe. Let's see. 1, no, you get out a 3, actually. And then put a 3 in, and you get out a 3. So that's good enough. So negative 1, 3, 1, 2, 3, 0, 0, 1, negative 1, 2, 0, and then 3, 3 over 3 up 3. So there we go, students. We have a parabola. And there we go. So now you're seeing what you get when you take a linear function and a quadratic and you add them together. There's a picture of it. Okay? Alright, moving on now to numbers 39 to 59. 39 to 59. And the directions for 39 say, hold on 1 second while I move my book here over a little bit. Okay, the directions for 39 say to take f of g of f of g of x, g of f of x, and then f of x. So here we go. Let's do the first one first. They want us to do g of f of g of x. So here we go. And here we go. Your outside function is f, so I'm going to write x squared. Then where the parentheses, put a really big parentheses. G is my next function, so put g in. And here we go. X minus 1 squared means x minus 1 times x minus 1. Multiply your x through. Multiply your negative 1 through. And you end up with x squared minus 2x plus 1, okay? And that's number 39. And let me check the book real quick to make sure that we are accurate. And we are accurate. Alright, so here we go. Moving on to the next one. G of f of x. function is g, so you write your g function, and then where the x is, you put a pretty big parentheses. Your inside function is f, so pick up f and put it right here. X squared minus 1 is x squared minus 1. Okay, moving on to, now look, f of x. So watch carefully. Your outside function is f, so you write your f function, okay? Then where the x is, you put a pretty big parentheses, and then you put f in because it says your next function is f, so pick up f, x squared, and put it here in the parentheses. So you have x squared raised to the second power, which would be x to the fourth power. Okay, alright, moving on to number 41. Alright, f of g of x, here we go. F function comes first, 3x plus 5. Where the x is, I'm going to put a pretty big parentheses. And then my next function is g, so I'm going to pick up g and put 5 minus x. Well, 3 times 5 is 15. 3 times negative x is negative 3x. Bring down your positive 5, and you're left with negative 3x plus 20. Negative 3x plus 20. Alright, moving on to g of f of x. Okay, here we go. Your outside function's g, so we write our g function. Then where the x is, we put a pretty big parentheses. And then my next function is f, so you pick up f and put it inside the parentheses. And you're left with 5 minus 3x minus 5. Your 5's cancel out, and you're left with negative 3x. Alright, moving on now to f of x. So my outside function is f, so here's my f function. Then where the x's are, I put a pretty big parentheses. Then I go to my next function in the problem, which is f, so pick up f and put that in the parentheses. Now take your 3 and multiply it through. 9x plus 15 plus 5 gives you 9x plus 20, which should be the correct answer, and it is. Alright, moving on now to numbers 43 through 51. They want us to find f of g and g of f and find the domain of each function and composite functions. Okay, so let's go ahead and get started with this. Here we go, number 43. Okay, students, here we go. First of all, we're going to find the domain of each of these functions real quick. Then we'll do f of g of x and g of f of x, okay? So the domain of this function here is x plus 4 has to be greater than or equal to 0. Bring your 4 over and make it negative. X is greater than or equal to negative 4. So there's the domain of the first function, okay? Did not mean to do that. Let's try that again. Now, the domain for the other function is going to be all real numbers. So I'm just going to put all real numbers, okay? Now, f of g of x, here we go. Okay, f functions first, so I'm going to put my f function right here. And then I'm going to put a parentheses where the x is, and then bring down my positive 4. The next function is g, so put g on the inside, x squared plus 4, okay? So we would have the square root of x squared plus 4. Now, students, let's go ahead and find the domain of f of g of x. Remember, you don't look at whenever you're asked to find the domain of your f of g of x function, or in other words, your composite function, you do not look at this. You look at your two function domains up here, and you find their intersection point, or in other words, where they both agree. So one of them says x is greater than negative 4. Okay, x is greater than or equal to negative 4. So here's 1. Okay, and the other one says all real numbers. And so, because it says all real numbers, that means everything is shaded in. So where do these two graphs agree? They agree starting right here and going this way. So the domain would be x is greater than or equal Then where the x is, you put a really big parentheses. Next is your f function, so pick up your f function and put it right here. So students, now if I simplify this, whenever you square a square root, you get x plus 4, okay? So it looks like your domain here would be all real numbers, but it's not. Again, you have to look at what you have up here and compare the two, where they intersect, okay, of the two, of your two given functions. So the domain, once again, for this is going to be x is greater than or equal to -4. Okay? Alright, moving on. Here we go. So students, I'm starting with my g function out here, so I'm going to write 3x plus 1. Then where the x is, I put a pretty big parentheses. Next is my f function, so bring your f down and put 1/3 x minus 3. Okay, take your 3 and multiply it through. 3 times 1/3 is 1x. 3 times -3 is -9 plus 1. So the composition would be x minus 8. Okay, now obviously the domain for that would be all real numbers because your two domains up here were all real numbers. Moving on to number 47. Okay, we're going to, first of all, your domain would be all real numbers, and your domain would be all real numbers for both of these. Okay, now f of g of x would be, put your f function. Now where the parentheses is, put a pretty, where the x is, put a pretty big parentheses. Next is g, so pick up g and put it right here. X to the 4th raised to the 4th is not x to the 8th. It is not. You multiply those and you'll get x to the 16th, okay? Very important you understand that. And so the domain would be all real numbers, okay? And by the way, I'm not going to take time and do g of f of x because common sense says you'll get the same thing because look, both of these functions are identical. So if you reverse the order, you're still going to get the same thing. Identical, so no need. Alright, number 49. The domain for x would be all real numbers. You can put anything in for x that you want to. The domain for this is all real numbers, okay? Now let's do f of g of x, okay? So pick up my f. My f function is this right here, the absolute value of x. So then I put a big parentheses where the x is, and then I'm going to put this function in, x plus 6. So I have the absolute value of x plus 6. That would be my composition, okay? And obviously the domain would be all real numbers because both of these were all real numbers. Now, g of f of x. Alright, g function comes first. Then where the x is, put a parentheses. And then pick up your f function, put on the inside, so the absolute value of x. So your final answer is the absolute value of x plus 6. And of course, again, the domain would be all real numbers, okay? Alright, moving on to number 51. Number 51. Alright, the domain for this would be x is greater than 0, because x cannot be 0. Oh, I'm sorry, that is incorrect, I apologize. It's all real numbers. I'm going to put AR in all real numbers, or AR hashtag, I guess, all real numbers, such that x does not equal 0, and over here it's all real numbers. Okay, alright, so here we go. F of g of x would be, f comes first, which is 1 over x. Then where the x is, we put a big parentheses and we put x plus 3. Okay, so there we go. So the domain, well, first of all, this would be my composition, okay? So the domain would be, think about this for a second. Again, you have to go with what this says, not the domain of what this would be here, okay? So, the domain for this would be all real numbers. Let's see, that do not equal 0, so all real numbers not equal to 0, okay? And again, it's going to be where the intersection of these two domains are, alright? Okay, moving on. Remember, you don't just look at this and find your normal domain. You take the domain of your composition by looking at these two domains up here. I'll go g of f of x. Here we go. Your g function is first, so you write your g function. Then where the x is, you put a parentheses, and then you put inside of that your f function, 1 over x. So I have 1 over x plus 3. Okay, now really you should probably simplify that. 1 over x plus 3. Remember, 3 is over 1, so I'm going to multiply x times the top and the bottom, which is legal, and that gives me 3x over x. Now that's okay, because if I were to reduce this, I would still get 3 over 1, but the reason I've done that is now I have a common denominator, so my final composition would be 1 plus 3x all over x. Okay, so your composition would be all real numbers, okay, except not equal to 0. Okay, all real numbers except not equal to 0. Alright, and that would be because, again, you're taking where these two domains agree. Alright, moving on to the next section. It's going to be numbers 53 through 59 odd, and we're going to try to rewrite the original two functions. Okay, this is a composition, so we're going to write the original two functions. And again, this answer I'm going to give you is not unique. There could be more than one answer, but I see here I have a whole group raised to the second power, so I'm thinking one function could be 1 over x squared, and the other function could be 2x plus 1. There we go. Okay, now again, I don't like how they have this written. I really don't. I'm going to put f of g of x. I really am. So this is my f function here, and this is my g function here. Do you guys see how I got that? There's really no way to teach this. You just got to look at it and see there's a group here raised to the second power. So I'm going to pretend there's an x there, and then I'm substituting this in for x. So f of g of x would give me this right here. Let's try another one, okay? Same thing. Okay, now look, I've got a whole group inside a cubed root, okay? So I'm going to call this f of g of x. Now, I've got a whole group to the third power, so a whole group. I'm taking the cubed root of a whole group, so I think my one function would be the cubed root of x. And then, what am I going to put in for x? Well, x squared minus 4. So this is my f of x, and this is my g of x, right here, okay? So, this is my f function right here. And if I'm trying to find f of g of x, I pick up g and put it in for x, and I get this right here. Okay, number 57. Okay, now here's what I see. I see a whole denominator that's x plus 2. Okay, so I'm going to cross this off, and I'm going to put f of g of x. Now, if this whole thing was x, one function's 1 over x. So what do I got to put in for x to give me x plus 2? Well, I've got to put x plus 2 in for x. So I'm going to call this my f function, and I'm going to call this my g function, and let's see if that works. Sure it does. F of g of x. Here's my f function. Put a parentheses for x. Put this in for my parentheses for my x, and I've got this right here. It's perfect. Alright, number 59. Now this one here, there's probably plenty of answers. In fact, there's quite a few answers I'm thinking of right now that you could go with. So I really don't know what to say. I'm gonna make this as simple as possible. I really am. There's more than one answer, guys, for all of these. F of g of x, okay? I'm just going to make my whole denominator x. That's me, okay? So I'm going to say my one function is negative x squared plus 3 all over x. And my other function is going to be 4 minus x squared. And that's definitely sufficient. There it is. So I'm telling you now, this is my f function right here. You know what, there's only one problem though I just thought of. I do have to make a substitution for both x's, so that would not work. So hold on 1 second, and let me think this through. Okay, students, I'm back, and what I'm thinking is this. I think this will work. I just kind of went through it quickly in my head. I hope this will work. I've got an x squared and an x squared. So what I'm going to put is I'm going to put negative x plus 3 over 4 minus x. Now, what would I have to put in for my x's to give me x squared? Well, I've got to put x squared in for my x's. So let's see if this works, okay? We're going to call this my f of x. We're going to call this my g of x. Okay, now, everywhere there's an x, remember, this function here is f of g of x. So everywhere there's an x, I'm going to put a parentheses and put x squared in, and that totally works perfectly. So this is sufficient, okay? Guys, I hope this homework help video has been a help to you. If you have any questions, never hesitate to